Okay, so this is the next question. I think the way I grouped these questions is basically whichever questions require two dimensions. Although the last one didn't. Forget why I grouped these questions this way. But let me just briefly show the question number. So this is the chapter 5 problem 80. Helps me with my editing later. So a body of mass. So this they've given us the mass numerical value 12 kilograms. So moving along the x-axis, okay, with a speed of 3 meters per second at the instant represented below. Okay, so they didn't actually draw an arrow or anything, but let me just draw it so I'm not confused. It's moving with some speed. V equals 3.0 meter per second. They didn't say towards the positive x-axis, but that's my assumption. If as I read the rest of the question, if I have to seriously consider was it moving in the negative direction, positive direction, then I'll do that. This is my initial assumption. So it asks, what is the acceleration of the body? So this is basically asking you to use Newton's second law. So they've given you a bunch of force information, and if you remember what you learned this week, then you remember Newton's second law, which says that net force as a vector quantity is equal to mass times acceleration as a vector quantity. And especially when we want to make it clear the causal relationship, we would say it's acceleration, which is being caused by the net force divided by mass. So here, I think to find the acceleration, all we have to do is first to find the net force and then divide by mass. We are given the mass. So let's find the net force first. Oh, I guess it's that vector exercise. Yeah, let me do it here. So I think the way I can organize my work best is to just write down the components. F3 looks easiest. I know the magnitude and it's all in the negative x direction. So I'll say this is in the, I'll use the I hat and J hat that the question is using. So F3 is minus 80 Newton I hat and no J hat, no Y component. And with F2 and F1, they both need a little more work. With F1, let me draw my right triangle this way. By the way, this right triangle drawing exercise, that's what I recommend that you go through each time, because that helps you visualize these angles you are given, and most importantly, ensures that you don't make mistakes about whether you sine or cosine with either of the legs. So you are using what you learned in trigonometry or even geometry before that. So, ka, toa, so sine meaning sine is opposite over hypotenuse. So so using that, opposite of this angle is this side. So this side should be F1 sine of 37 degrees, and this side should be F1 times cosine of 37 degrees. This is the adjacent side, so from ka, cosine is adjacent over hypotenuse. Hopefully you've had enough practice with that, so I don't have to write those down in detail. If somehow you need that, look at maybe I should. Let me do that with the F2. So with the F2, the way this angle is labeled, actually the association of sine and cosine with the different sides will be different. So if you kind of this automatic association with the x and y components, and you do, oh, this is y component, so F2 sine 30 degrees and F2 cosine 30 degrees for the x component. If you did that, you'll get wrong answer, because the way they gave you the angle, this doesn't work. So let me write this out. So to find these sides, basically, this is the quick algebra step that you are going through. So I'm just going to label this F2y and label this as F2x. And what so and ka tells you is that sine of the angle is the opposite. That's F2x, the way this geometry works out. F2x over the hypotenuse, the magnitude of F2. Which one is the x component? So you solve this for F2x, then you get F2x is equal to the, I move the hypotenuse term over, so F2 times the sine 30 degrees. F2 times the sine of 30 degrees. Even though it's x component, what I have to deal with is sine because of the way geometry worked out. For the y component, you do the same thing. So you realize, oh, I can use it's adjacent side, so I can use ka. And what that says is cosine of the angle is the adjacent f to y divided by the hypotenuse f2, and that's f2. And solving it for f to y, you get f2 cosine of 30 degrees. And something similar to this is basically what I did here, just mostly in my head and by habit. So those are all the terms. I think what's going to be the easiest is to just do this calculation in Wolfram alpha. I'll just type everything out here because there are so many numbers. I think it's going to be easier just typing stuff in. Let me see if I can do it in vector notation. So I'm gonna do x component and then y component all in just one shot. So x component, let's do f1 plus f2 plus f3. So it's gonna be f1 cosine of the angle associated with f1. So 50. Do I have to say Newton? Yeah, let's say Newton. Times cosine of 37 degrees. And then I have to mind the directions. The f2x, it's going in the negative direction, so I'll say minus 30 Newton times the sine of from here, sine of 30 degrees. And then still minding the directions, f3, it's minus 80, just the whole thing, minus 80 Newton is equal to not equal to yet. I need to do the y component. So for f1, I have plus 50 Newton times the sine of 37 degrees. F2y is going in the negative direction, so again minus 30 times this time cosine of 30 degrees, and then 0 from F3, so nothing there. So yeah, that's both the vector components. Now when you put it in that way, will that be too complicated? No, not too complicated. But it's not giving me decimal approximation. Decimal approximation of, will it do that? No. That is annoying. I don't want exact result. Actually, is it doing something? Use it as a unit instead. Was that why it was doing? Okay. Sorry, let me go back. So I had a reason for putting in Newton here. So if you put this in, it'll say it's wrong because that's the net force. You want the acceleration. So let me get rid of Newtons. Or I think the way the calculator is working out, this is more confusing than helpful. Let me not have the Newtons there. So this is the net force. To get the acceleration, you divide it by mass, or I can multiply by 1 over the mass, 12 kilograms. And it's all in basic SI units, so I didn't really need Wolfram alpha to do unit conversion for me. So let me just leave it here. And yeah, that's the form. And there it is, decimal approximation. So that should be right. Let's just try it and see. Minus 4.589. I'm keeping on x. Well, actually, I guess I can round it to 3. Minus 4.59. And then 0.342. Good. Let's keep going. Wait, where? Oh, I see. Those I and J moved. Let me just erase this. And then, so after this, the rest is actually just kinematics questions. So we use the Newton's second law to figure out the acceleration. And once you have the acceleration, the parts B and C, it's asking about the velocity and displacement. It's asking you to basically use your kinematics knowledge. That velocity as a function of time is some initial velocity plus acceleration times time. And the way this question is set up, let's make sure they are all vector quantities. And your final, let me use the letter that the question is using, your position as a function of time is your initial position plus the portion that's attributable to initial velocity plus 1/2 the portion that's attributable to acceleration, and this is technically a vector expression. Oops, square, t square. So that's all it's asking you to do. So they gave us the initial velocity. I guess this is why they gave us the initial velocity. So we'll just write this out. I think we have the acceleration from up here, and we just we can just tack on the rest. We are given the time and all that. So let's do that. Oops. This way. All right. So this is the quantity that's here is acceleration. Let me just remember that. And I'm gonna multiply that by time, 10 seconds, and I need to add the velocity. So let me do the velocity in the vector format. So in adding initial velocity, all I'm doing is 3.0 the times I hat meter per second plus 0 times j hat meters per second. That's my initial velocity, and this is the time. This whole thing should still be the acceleration. So with that, we get, let's see here, I hope there's a decimal, there's minus 42 point, I guess that's right. Yeah, there's a big negative force in the negative x direction. So I think that's right. Let's plug in the numbers and see. Yeah. Right, the 3, yeah. Because I think this is just like 10 times that from 10 seconds, but 10 times that, but I have to subtract of 3, so I think that's right. Maybe. I mean, if I'm rounding to same significant figures, it should be that. So I think that's right. Says no. It's probably a bug in the question. Let me just, let's check what the answer key says. And then I can tell you if that makes sense or not. So the answer key says this. Yeah, I'm pretty sure it's a bug in the question, and I've seen similar bugs before. What I would suspect is question display is telling us 10 seconds, but internally it generated a random number. That's that's what the answer key is using. So what I can do is I can actually figure out what the internal version of the number is. Let me do it this way. 3.28 divided by 0.342. So I'm pretty sure the question has used the 9.6 second as the time. That's my guess. Because if I make this 9.6, then I'll get the right answer. So wait. Oh, it might also have done this with the initial velocity, because like this doesn't match that. So I also have to figure out the. Let me do it this way. So with a guess about the time, I can at least do this much. I can do this surgery to this expression. So I'm trying to use this formula for position to get the final displacement. So it should be a 1/2 acceleration times. So this is the acceleration. Let me do 1/2 times the time that I inferred squared plus, now the nice thing about the y component is your initial velocity is 0. Don't have to worry about it. Your initial position, we are looking for displacement, so this is 0. So if I just do this, then that should give me the correct answer for displacement with the 9.6 second that the question internally uses. The y component, this should be correct. Let's see. Yeah, that's correct. Good. This is not the actual correct answer. The actual correct answer would be using 10 seconds with the question display. But this experiment, which only I think I can do, you don't know the correct answer, so you can't do this backward inference on your end. So let me just write down so I don't confuse myself. So I'll say because question error, it uses time of 9.6 seconds instead of 10. And I also need to figure out my actual the code version of the initial velocity. So let me go back and do that, and then we can wrap this up, and I'll file an errata with the question author so that they can fix it. If the question code is using this as the initial speed, then this minus 41.0, that should be the correct answer, but it's not, because so I think what I need to do is so if I do so this should give me delta V. So the delta V is minus 40. So so I guess I can do the this delta V. So the final speed, that's minus 40.08, 3.42 minus the delta V should give me the initial speed. Yeah. So the initial speed that the question code is using is 3.97. So now I can backtrack and calculate the delta, full delta R, using those for the information. So this is the portion that comes from the acceleration, 1/2 times this 9.6 is the time calculation is using, squared plus the initial speed, 3.97 and 0 for the y component, times time, I need times 9.6 plus, I don't need that because it's a displacement. This I can set initial position as 0. So with that, we should get an answer that the system will grade as correct. It's not actually correct. Minus 7.5. It really should be fixed so that it displays you the correct information. So so let me just do a. I'm just gonna click on this so that I have one as a reminder that I need to file an errata. So yeah, but in terms of actually doing the question, not that hard. All you have to do is the vector sum of the forces, and once you have the vector sum of the forces, that divided by mass gives you the acceleration, and the rest is kinematics. And if there were errors in the question, this would have been graded as correct, and the actual correct answer here would have been one that's based on the 10 seconds and the 3 meters per second here for initial velocity.